In this video, I'm going to explain about the construction of the silicon control rectifier. Now, the silicon control rectifier is one of the device which falls under the thyristor family, and we also have other devices which falls under thyristor like GTO, gate turn off thyristor, and we also have reverse conducting thyristor, which is represented by the RCT, and we have again the static induction thyristor, which is represented by the SITH, static induction thyristor. And we also have the gate assisted turn off thyristor, which is represented by the GATT, gate assisted turn off thyristor. Then we also have the light activated silicon control rectifier, LASCR, light activated silicon control rectifier. And we have again MCT, MOS control thyristor, and we also have the TRIAC, TRIAC. Okay, now these are the device which falls under the thyristor. So our today's video, I'm going to explain the construction of the silicon control rectifier, SCR. The figure at the left side is the detailed construction of the silicon control rectifier. Now if you look into this one, you will see 4 layers of PN device. Now this P and N are the semiconductor device, right? And each layer has different concentration level, and then thickness is also different. So the difference with these 4 layers of PN device is each layer has different doping level and thickness is also different. You should understand that in the SCR you have 4 layers of the PN device. Each layer has different doping level, and thickness of each layer is also different. And then it has 3 terminals. Their gate, cathode, and anode. Gate is represented by G, cathode is represented by K, and anode as A. And now because of the 4 layers, now it has 3 junctions, J1, J2, and J3. Now we are going to discuss the reasons for having different doping level and then the thickness. Now if we start from the bottom, from this, at the bottom layer, and this side, in the construction we have 2 layers, P and P plus, but we are making this one as P layer, and it forms the anode of the silicon control rectifier. Now this P and P plus has different doping level. Again, the concentration is different, 10^17 per centimeter cube for P level, and for the P plus it is 10^19 per centimeter cube. So because of this higher doping level, it is connected at the anode side. And then after this, Okay, now the thickness of this p layer, which is combination of p and p plus, so it is like 30 to 50 micrometer. And the next layer is we have n minus layer. So n minus layer is less concentrated or is lessly doped comparing to other layer. Like the concentration level is 10^14 per centimeter cube, but it has that the width, the thickness of this layer is more, okay, higher than other layers. The reason for having this higher that the thickness bigger than the other layers is it observes the depletion layer formed at junction J2. Now you will understand that when we discuss about the working principle of the working process of this SCR, you will understand that okay, when PN, here you have gate, you have cathode, you have anode. When this anode is positive with respect to cathode, so this junction J1 will be forward bias and junction J2 will be reverse bias, junction J3 will be forward bias. So during that time, depletion region is formed at junction J2. So this junction J2's depletion region is absorbed by the this n minus layer. So because of this, now n minus layer has a thickness of 52,000 micrometer. So which means it that the size of the SCR is almost all contributed by the n minus region. And then also, in order to decide the forward blocking capability or the forward conduction capability, it is decided by the thickness of the, okay, this 2 is decided by the n minus layer, the thickness of the n minus layer. So if this thickness is less, the forward blocking capability will get changed. If it is thick, forward blocking capability will be again changed. Okay, so in order to determine the forward blocking capability or the forward conduction capability, it depends on the thickness of the n minus region. Now next we have, okay, we done with the p layer, n minus layer, okay, p layer, n minus layer, and then again we're back to p. Now this p is again it gives the position for the gate terminal. This p layer gives the position for the gate terminal, and it is doped 10^17 per centimeter cube, and then thickness is 30 to 100 micrometers. See, if you compare with the n minus, so let's also write n minus. For n minus it's 52,000 micrometer. For the p layer it is 30 to 50 micrometer. So later on we can compare. See, comparing to p and n minus, this one is greater. Again comparing to the next p, again this one is greater. So the reason is it absorbs the depletion layer which is formed at the junction J2. Okay, now doping concentration for this gate terminal, that P level is 10 raised to 17 per centimeter cube, and then thickness is 30 to 100 micrometer, and it forms the gate terminal. So it gives the position of the gate terminal. And the next layer is we have N plus. So N plus, this one it gives the position or the terminal for the cathode. For cathode, it gives the position for the cathode, and this is the last layer comparing to other. And then the thickness, okay, the thickness for this one is less. Thickness for this one is less comparing to other layers. Now with this we cover that silicon control rectifier is made up of the 4 layers of the NP layer devices. Okay, and N plus layer forms the cathode terminal, which is represented by the C, and next to N plus it is P layer, and it forms the gate terminal, is represented by the G. And then we have N minus, and then function of the N minus is to absorb the depletion region. That's why it is thicker in the the width. And for the P, it is it forms the anode terminal. And then and again inside the P it has 2 region, P and P plus. So there's again the doping differences in the concentration level. So that's it. And in the next video I'm going to talk about the working principles, the working conditions of the SCR device. So in that working of the SCR, I will cover the VI curve or the VI characteristics, and then there are again different types of the mode of operation. Okay, mode of operation, and the different types of to activate the SCR. So in the next video I'm going to cover this 3. Okay, that's it.